code.
Okay, so this is a short description of the retrieving comparative argument task approaches, ensemble methods approach, and neural information retrieval. So I should move this panel. Okay. The task is the following. Assume we have a set of topics with comparative query. It's a question like which is better, X or Y. And for each topic, we should retrieve documents from Clue Web 12 corpus by Charnois search engine, and we should rank documents in accordance to most full and reasonable comparison. In the bottom of the slide, there is example of query and documents. The query is which is better for environment, a real or a fake Christmas tree, and the top documents has the highest relevant two. The middle documents has the less relevant, and the bottom documents is not relevant at all. The organizer provides 50 topics with comparative questions, and besides, organizers also provide 50 topics with corresponding relevance annotation of the previous year competition. So it was 50 topics with references, and we use these topics with references to learn to rank task to train some our models. We split these 50 topics from previous year to 40 topics, train set, and 10 topics, validation set. And we use the following approaches to ranking: ensemble of trees and ranking BERT model. To use ensemble of trees, the first approaches, we use PyTerry platform for information retrieval. PyTerry platform provides the extraction of the text features, information retrieval adaptation of ensemble model, and using PyTerry, you can halt and express information retrieval experiment. So we choose the following ensemble models: random forest, XGBoost with lambda mart objectives, and LightGBM with lambda mart objectives. Lambda mart is a combination of lambda rank. Lambda rank aim to minimize number of inversions in ranking, and mart. Mart is a multiple adaptive regression trees, is an implementation of boosted method. And we use three set of features to feed these ensemble methods. The first set is features based on statistical language models. The second, it's one feature, is Charnois relevant score. Charnois relevant score is a score which is retrieved with the documents by Charnois, and it is counted based on custom BAM25 ranking function based on inverted index. And the last set of features is comparative based features. So how we use feature selection? In PyTerry, there is an ability to count extra features among the over the text by several language models like TF, TF-IDF, PL2, and so on. And to select the most informative model for feature, we try 7 language model, and by this feature, we rank documents in the validation set and see and choose the language model which give the best score. So in the bottom of the slide, there is a table with these 7 model we have tried and with the score which this model gave. So we select BAM25, DFIC, TF-IDF model for creating extra text features. The next set of feature is comparative set. Comparative sentence can be described, the issue of the comparative sentence can be described by the comparative structures. It's objects for comparison, aspects, and predicate. We applied the sequence labeling model to the every topic, and this sequence labeling model gives us the objects, aspects, and predicate which this model found in the topic. So we take this object, aspects, and predicate and try to find it in the every document from the retrieved set. And based on the result, we count the following features. The feature is retrieved describes are there any comparative structures in the document at all. Object score defines how many objects from topics are found in document. And our spread score is counted in the following way. If at least one object from a topic is in the document, and the document also has aspects or predicates, every aspect and or predicates in document decreases the score to 0.5. So the next big approach is re-rank based on BERT. We use OpenNIR library to use BERT architecture to ranking task. This library provides this library provides BERT for ranking as BERT for regression task. So in this case, ranking is like a regression. In this library, we use vanilla transformer architecture, and this was a scratch, and we should train it. So BERT is a quite complicated model and need a lot of information for training, so we should retrieve some additional data set except 40 topics from the previous year. And for train BERT, we use antique data set. Antique data set contains approximately 2,000 non-factorial questions from a diverse set of categories. And the example of antique data set is in the bottom of the slide. Queries: how do we put the letter K on the word knife, knob, knee? And there is 4 documents which was ranked according to the relevance of this query. This is topic from antique data set, and using antique data set we train BERT during 500 epochs with learning rate 0.001 and batch size 56. And then we fine-tune BERT during 10 epochs with 40 topics from train set. Then we take all our approaches and apply it to topic on validation set and see how good our approach is on validation set. This table presents the result, and according to this table, the best result comes from LightGBM model. The XGBoost have the less score. The baseline from the previous year has score less than XGBoost. Random Forest has score 0.48, and BERT has a score 0.412. So we also see the feature importance, which was provided by LightGBM. So in the bottom of the slide, there is a feature importance for every feature we used. And as you can see, the most important feature is Chat Noir score. Then some statistical feature is it is D5C and PL2, then go objects and aspect predicates, then go TF-ADF, and feature is retrieved. According to the LightGBM, it's not a very important feature. So our answer were validated on a test set in 2 directions. The first direction is relevance. Relevance describe how full and reasonable the topic answer. How full and reasonable the document answers the question in the topic. And according to this direction, the best score comes from XGBoost, and XGBoost have top 1 in this year. The lesser score has LightGBM. Then go baseline, then go random forest, and BERT ranking has not very good score according to the relevance. The next direction was quality. Quality describes how fluent and grammatically correct given text is, and according to this direction, the best score have the light GBM. Light GBM has a position 2 in the whole table slanted surrounding the Rayleigh theme. Then goes XGBoost, then goes baseline, random forest, and BERT. BERT in the quality direction has a better performance, but the least performance among all the proposed model at all. So there is an example of the output. The question is admission rate in Stanford higher than that of the MIT? And in the left column, there is light GBM top 3 output. And in the right column, this is baseline top 3 output. So yeah, I think I should go to the next slide, and you can see this slide more precisely later. So the conclusion is the following. We apply several approaches to the argumentative and shared task. We use ensemble methods and method based on transformer architecture. The best score give gradient boosting models. Transformer-based model gives not very high performance, and perhaps this is due to the lack of relevant data for training. So as I understand, our BERT train very good to answer the non-factoid questions, but not comparative. So that's all. Thank you for your attention.